a few extra minutes to submit your script. So either you scan it on a scanner or you use your phone with a scanning app. So I hope you have got one already and you know how it works. Usually it's just one attachment that you're allowed to do. So if you have several PDFs, you should know how to merge them and make them into one PDF. Okay, do we have any questions before we get started? Okay. If there are no questions, then we will just continue. I also sent you guys the test dates or the amended test dates with the assignments. So we'll write the test on the 4th, and then 2 weeks later there's another one, and so on. So we'll still have 4 tests compared to the 3 that we were supposed to have. Okay, so we have a lot to cover. You guys will have to try and keep up. Remember, if you're having problems, you can contact me on Teams, send me an email, or on e-learning. I'll always respond to you there. Okay, so yesterday we were talking about elimination. We say that if you have linear equations with 2 variables, you can always solve. Okay, somebody wants to join the class now. Okay, you can always solve it using elimination. Now, the way elimination works is that you get rid of one of the variables and remain with only one, and then after that you get rid of the other one, and then you remain with the one that you didn't solve for. Okay, so it's pretty simple to do. Now, the second method of solving simultaneous equations is by substitution. Okay, now substitution, just like the word suggests, this means to replace. Okay, so you know when we talk about a substitute teacher or a substitution in a soccer game, it means somebody goes out and then another person replaces them. So if the goalkeeper goes out, the person who comes in must also be a goalkeeper. Otherwise, I don't know what substitution you're making. Okay, so you must take the place of the person that you are replacing. So that is what substitution means. So you'll have an equation. Let's look at an example. We have this one here, 2x plus 3y. And this is equal to negative 2. And then 4x plus y. And this is equal to 6. Okay, so this is the question we solved using elimination. Now we want to try and see if we use substitution, do we still get the same answers? And the answer is yes, we should get the same answers. Now with substitution, what you need to do is you make one of the variables the subject of the formula. So number 1, you need to make x or y the subject. So you pick one of the formulas to make x or y the subject in. It doesn't matter which one you pick. And then what you will do is you substitute it into the other equation. Okay, so it's good to label them. This is equation 1, and then this is equation 2. So from equation 2, what I'm going to do is I will make y the subject of the formula. Okay, then the third step over here is just to solve. Right, so let us look at how we do that. So we have 4x plus y, and this is equal to 6. Now we want to make y the subject of the formula. Remember, we did manipulation of formula. You should be comfortable with changing the subject of the formula with just about anything. Then what you can do is you can subtract 4x on both sides. So you have y is equal to 6 minus 4x. Okay, so this is your equation where y is the subject of the formula. And what you're going to do is you are going to substitute this y over here into your equation 1. So you don't substitute it back into the equation where you got it from. It has to be substituted into the other one. So let us do that. So now we substitute into equation 1. And equation 1 was 2 times x plus 3 times y. Now the y that I'm going to put is this one that I have over here. So this is 6 minus 4x, and this should still be equal to minus 2. So everything else in the equation must be or must remain the same. The only thing that I'm going to change is this value that I have substituted. Okay, so only the y is going to change. Everything else must remain exactly the same. So now I have a linear equation with only one variable. This is very easy to solve. So I will multiply this out. You know how to multiply brackets out. So I have 2x plus 18 minus 12x, and this is equal to minus 2. Okay, then as usual, everything with x on one side, everything without x on the other side. And these 2x and minus 12x, we can combine them. And then when we combine them, we get minus 10x. And this is equal to minus 2 minus 18. This is equal to minus 20. Okay, so I subtract 18 on both sides, and then I combined the 2x and the minus 12x. Then I want x to be the subject of the formula, so I'll divide by negative 10 on both sides, divide by negative 10, divide by negative 10. So this means that x, this is equal to positive 2. So it is positive because I'm dividing negative with a negative. My answer should be positive. Okay, and if you remember from what we did yesterday, the value of x was also equal to 2. Okay, now let's solve for y. We know our formula for y. It is this one, 6 over here. So we have 6 minus 4x. That is our formula. But now we know the value of x. So we will replace the x that we got over here right there. And then we solve it. So this is 6 minus 4 times 2. This is 6 minus 8. And this is equal to negative 2, which again is the exact same answer we got yesterday by using elimination. Okay, so we can write our solution like this: x, y, and this is equal to 2, negative 2, or x is equal to 2, and y is equal to negative 2. So either one of those is fine. So remember, these are a pair that go together. X is 2 when y is equal to negative 2. And that's how we solve that one by substitution. So very simple to do. All you have to do, you have to choose which variable you want to make the subject of the formula in one of them. Then substitute it into the other equation, and then after that what you do is you solve and then go back and solve for the one that you made the subject of the formula. Now let's look at exercise or 4.1. Okay, now when a question comes and it says solve simultaneously, it is up to you which method you want to use, whether you want to use elimination or substitution. You're not restricted. If it does, however, say use elimination, that is the only method you are allowed to use. Okay, so if it doesn't restrict you, go ahead and use whichever one you want to do. But if it is specific, then make sure you use that specific method. Okay, let's look at number 1. We have 3x plus 2. This is equal to negative 2y. And we have 5y. This is equal to negative 4x minus 3 over 2. Okay, now you'll notice this one is written a little bit different in that I don't have x and y on one side of the equal to sign compared to the other ones that I had. It was always x and y on one side and then your constant on the other side. So here what you can do, first decide on the method that you want to use. Since we just started with substitution today, I will choose to use substitution. So I will label my equation. This is equation 1. This is equation 2. Okay, so I'm going to make y the subject of the formula in equation 2. So from equation 2, to make y the subject of the formula, all I need to do is multiply by 1 over 5 on both sides. So if I multiply by 1 over 5 on the left-hand side, I'll be left with y. And then on the right-hand side, every single term, so this one has to multiply by 1 over 5, that has to multiply by 1 over 5. Then I'll be left with minus 4 over 5x minus 3 over 10. Okay, so that is what I have. I have multiplied by 1 over 5, which is the same as dividing by 5 on both sides. Then, now that I have this value of y over here, what I'm going to do is I'm going to substitute my y value over here into the other equation. So see here, I used equation 2. Then when I substitute, I must substitute into equation 1. Do not substitute it back into equation 2. You will get something like 0 is equal to 0, which doesn't make sense. Okay, well, not that it doesn't make sense, but you cannot do anything with that. Okay, so now we make the substitution. So I have 3x. So remember, I'm only substituting the y, so everything else must remain the same. So I have 3x plus 2. This is equal to negative 2. And then I have negative 4 over 5x minus 3 over 10. Then I will multiply out the brackets. Remember how we do that. On the left hand side, nothing has changed yet, so I leave it as 3x plus 2. And then on the right hand side, the negative, excuse me, the negative 2 times the negative 4 over 5, that will become positive. So I have positive 8 over 5x. And then again, negative 2 times negative 3 over 10, that will become a positive value. And then this 2 here will cancel with the 10 that you have over there. And then you'll have 3 over 5. Okay, that's what we have. Then we've worked with equations like this before. We said that we do not like to have fractions. So as much as possible, we try and get rid of the denominators. So here the denominators are the same. So what I do is I just multiply throughout by the denominator. So I multiply by 5, multiply by 5, multiply by 5, multiply by 5. So I multiply every single term by 5. And remember what makes a term. Terms are separated by plus or minus. So I'm not going to multiply the 8 over 5 with 5 and then the x also by 5. No, because they are one term. Okay, and then when I do that, what I get is 15x plus 10. This is equal to 8x plus 3. Okay, so those two will cancel. Those two will cancel. And then this is what I will have left. Then again, everything with x on one side, everything without x on the other side. So on the left hand side, I'll subtract 8x. So I have 15x minus 8x. And then on the right hand side, I will subtract 10. This is 3 minus 10. Now 15x minus 8x, this is 7x. And then 3 minus 10, this is negative 7. And then I will divide by 7 on both sides. This means that x is equal to negative 1. That is my first solution. Okay, then I need to go back to the equation where I made y the subject of the formula, and here it is. And then what I will do is I will substitute x into that equation to solve for y. So what I have is this. Y is equal to negative 4 over 5 x minus 3 over 10. Okay, minus 4 over 5x minus 3 over 10. Then what I do is this value of x, I'm going to substitute it over there. So this negative 1 is what I'm going to substitute over there. All right, so let's make the substitution. So I have y, this is equal to negative 4 over 5 times negative 1 minus 3 over 10. So this is equal to 4 over 5 minus 3 over 10. Okay, and this is 8 over 10 minus 3 over 10, and this is just 5 over 10, and 5 over 10 is just equal to a half. Okay, so we solved for x. We got x is equal to minus 1 and y is equal to a half. We can write it in this form. X, y is equal to minus 1 and a half. Now again, very important, you always have to check your solutions. See if the values that you have gotten are correct. Okay, so you'll substitute your value of x and y into both equations. So what you'll do, you'll take your original equations, which is these ones over here. You substitute x is minus 1 and y is a half. See, does it satisfy this equation? If it does, then that is correct. Then you also check in the second equation, does it satisfy it? If it does, then your answer is correct. So I'll leave the checking to you guys. Let's see, the next one we have 0.7. This is number 2. 0.7 m plus 0.3n minus 0.8 is equal to 0. And then I have 1.2 is equal to 0.2m minus 0.4n. Okay, so that is what I have. Now you'll notice again, it is not in the usual form where m and n are alone on one side, or the first equation anyway. But here we can use substitution. So what I will do is I will make n the subject of the formula from the first equation. So this is equation 1, and this is equation 2. Okay, so it doesn't matter which variable you choose to make the subject of the formula as long as you follow the procedure. So I will rewrite equation 1. So from 1 over here, I have 0.7m plus 0.3n minus 0.8. This is equal to 0. So I said I want to make n the subject of the formula. So what I will do is I will subtract 0.7m and add 0.8 on both sides. So I'll end up with 0.3n. This is equal to 0.8. It becomes positive minus 0.7m. Okay, then what you do is you can divide both sides by 0.3. You divide by 0.3, divide by 0.3, and you divide by 0.3. I have n 0.3 divided by 0.8 divided by 0.3. This is just 8 over 3. This is 8 over 3. And 0.7 divided by 0.3. This is just 7 over 3. And then your m should be there. So I've made it the subject of the formula. And what I will do now is I will substitute it into into the other equation. And here, avoid using decimals that round off, like 8 over 3 as a decimal is 2.666, and it continues like that. So if you round it off, the answers you get will also not be accurate. So rather work with the fractions the way that they are. Okay, and then we said now we're going to substitute this value of n into the second equation. And the second equation was this one here. 1.2 is equal to 0.2m minus 0.4n. So let us do that. So I have 1.2. And this is equal to 0.2m minus, okay, I'm going to write this down here so I have some space, 0.4n and then the value of n, this is 8 over 3 minus 7 over 3, and then I have m over there. So the 0.8 will multiply inside like that, and then I will simplify as far as possible. So we have 1.2. This is equal to 0.2m. And remember this minus here. This minus is the sign of the 0.4. So it's also going to multiply inside the brackets. So I have negative 0.4 times 8 over 3. I get 16 over 15. And then when the negative multiplies the negative, so this negative here multiplying that negative over there, my answer is going to be positive. And that will give me 14 over 15. This is plus, okay, 14 over 15. And this is m over there. Okay, so just be careful with your negative. Then again, we collect our like terms. I will add 16 over 15 on both sides. So I have 1.2 plus 16 over 15. And then on the right hand side, I have 0.2m plus 14 over 15m. So those you can just do on your calculator. Here I have 34 over 15. And here I have 17 over 15. Okay, just a moment. Somebody wants to join the class. Okay. Right. So if that is what I have, then excuse me. So you can see what I can do is I want to get rid of this. So I want to make m the subject of the formula. So I can multiply by 15 and then divide by 17. So I will have m is equal to 34 over 15 times 15 over 17. So if I multiply by 15 over 17 on both sides, you will see that this coefficient of m will disappear. So these two cancel. And then 17 goes there once, and it goes there twice. So what I have is m is equal to 2. Then I need to go back and solve for n. So n, remember n, the formula is over here, 8 over 3. I will just rewrite it. N is equal to 8 over 3 minus 7 over 3 m. Okay, then I substitute the value of m. So this m here, I will now substitute it over there and see what we get. So we have n is equal to 8 over 3 minus 7 over 3 times 2. Okay, here the denominators are the same. So I have 8 minus 14 over 3. Okay, so when the denominators are the same, we can combine the numerators. So the 7 will multiply the 2. That's where I got the 14 from. And this is just equal to negative 6 over 3. And this is equal to negative 2. So I have my two solutions for m and n. So we can say that m is equal to 2 and n is equal to minus 2. We can write it like this, m and n. This is equal to 2 and negative 2, like that. And then as usual, you need to check your solutions, make sure that you have worked them out correctly. Okay, so when you're checking, remember you must substitute into both equations. So here, substitute into both equations. Okay, this is very important. The solutions may work for one of the equations, but not for the other one. So very important to check that they satisfy both equations. Okay, so if they don't satisfy both equations, then you need to go over your working and see what you did. Okay. Right, let's look at number 3. Number 3, we have a over 5 plus b over 2. And this is equal to negative 2. And then we have 3a minus 2b over 6. This is equal to 9 over 2. Okay, so with this one, because I want us to practice using both methods, I will use elimination to solve this one over here. Okay, so remember with elimination, what we're interested in is the coefficient of whatever variable you're trying to eliminate to be the same. So what I can do is, with the first one, if I just leave it as it is, and then the second one, I can rewrite it. This is number 1, and this one is number 2. So from number 2, I can rewrite it. This is 3a over 6 minus 2b over 6, and this is equal to 9 over 2. So this is just a over 2 minus b over 3, and this is equal to 9 over 2. Now when I look at the two fractions, let me write the first one again. So this is the second one when it has been simplified. Now I'll write the first one again. First one was a over 5 and plus b over 2, and this is equal to minus 2. Okay, so let's say I want to get rid of a. The coefficient of a in the first equation over here, this is a half, and the coefficient over here is 1 over 5. So obviously they are not the same. So what I can do is I can make both coefficients equal to 1 instead of half and 1 over 5. So to do that, I will multiply the first one by 2 throughout. So multiply by 2, multiply by 2, multiply by 2. And then the second equation, I'll multiply by 5, multiply by 5, and multiply by 5, because I want the coefficients of a to be the same. So when I do that, what I have is this. So I will have a minus 2b over 3, and this is equal to 9. And for the second equation, I will have a plus 5b over 2, and this is equal to minus 10. Okay, now that the coefficients of a are the same, I need to say, are the signs the same or are they different? So in the first one here, this is positive. In the second one, it is also positive. So when the signs are the same, you need to subtract. So here, you must subtract. So you subtract what is at the bottom from what you have on top. So you will say okay, so you will say a minus a, that is 0. And then negative 2 over 3 minus, here, negative 2 over 3 minus 5 over 2. There you should get negative 19 over 6b, and then negative 9 minus, over here, 9 minus negative 10, this is 19. Okay, so what we have left is negative 19b over 6, and this is equal to 19. So what you do is you multiply by 6 and divide by negative 19 on both sides. So we have b is equal to 19 times negative 6 over 19. So you'll see that your 19s will cancel, and then you'll be left with b is equal to negative 6. Okay, then because we're not told what method to use, it's up to you to decide. I can now choose to bring substitution as the method that I will use to solve for a. Okay, so what you do to use that method is you pick one of the equations that you started with and then substitute the value of b that you got into the equation, into that equation. So I'll pick the first one. This first one, this was a over 5 plus b over 2, and this is equal to negative 2. So I know that b is negative 6, so I will substitute that negative 6 over there, and then I will solve for a. Okay, so doing that, I have a over 5. This will become negative now, so it's negative 6 over 2, and this is equal to negative 2. And then I can simplify. I will have a over 5 minus 3. This is equal to negative 2. This means that a over 5, this is equal to positive 1. Okay, so I will add 3 on both sides. That is where I got the 1 from. And then to get rid of the denominator, multiply by 5 throughout. So I have a is equal to 5. So I have my two solutions now. So I have a is equal to 5 and b is equal to negative 6. Or I can write it like this, a comma b, this is equal to 5 comma minus 6. So that is how you would solve them. So you can see that the coefficients of a and b or x and y or whatever variables you have, they don't really matter because you work it out in the same way that you do. I think we can just look at number 5 and then number 4, 6, and 7. Those ones you can do as homework. So I'll start here, homework. Number 4, 6, and 7. So the answers are already given to you over there. You just need to work it out and then confirm them in a way. Okay, so you know what the answers are. Show the working. So I'll look at number 5. Number 5 is a little bit different in that your coefficients are letters instead of numbers, but the procedure we use is exactly the same. So I have ax plus by, this is equal to m, and then I have cx plus dy, and this is equal to n. So here again, you can use elimination if you want to. There's nothing wrong with that. You can also use substitution, but substitution might be easier to do. So you have equation 1, and this is equation 2. So I will make x the subject of the formula in equation 1. So I have equation 1, I will just rewrite it. So this is ax plus by. This is equal to m. So I want to make x the subject of the formula so that I substitute that into equation number 2. So when I do that, I have ax, this is equal to m minus by, and then I divide by a throughout. So I have x is equal to m minus by over a. So this is my value of x, and this value of x, I'm going to substitute it over there and solve for y. So I have c times x. So I have c times x, which is m minus by over a plus dy, and this is equal to n. And then you can multiply out the brackets, so I will have cm minus cby, this is all over a, plus dy, and this is equal to n. Now remember what we want to do here. We want to make y the subject of the formula, and we have done questions like this before. So what you do, you multiply out the denominator. So you multiply by a times a times a, and then times a on the other side. And then what you have left, you have cm minus cby. The a's will cancel. Then I have plus a dy. This is equal to a n. Then you continue everything that has y on one side of the equal to sign, and everything that does not have y on the other side of the equal to sign. So I will be left with a dy minus c by. This is equal to a n minus cm. Then here you must factorize. You can see y is a common factor. So you will take the y out, and then you have AD minus CB, and this is equal to AN minus CM. Then this means that y is equal to AN minus CM over AD minus CB. Okay, so that is your value of y. Now notice in your solution of y, there's no x written anywhere. It is only in terms of the coefficients, and that means you have solved it. So I could not have stopped over here. See here where I have x as the subject of the formula. This will not be correct to say this is my solution of x because it has y over there. Your final solution should only be in terms of the coefficients. So in the formula for x, I should not see y, and in the formula for y, I should not see x. So now we solve for x. We say that x is equal to m minus by over a. So what I will do is I will take this y and put it over there and then solve. So I have x is equal to m minus b . Okay, and the value of y, this is an minus cm over ad minus CB, and this is all over A. Okay, so here it's just simplifying because X is already isolated, so I just want to write this nicely. So I have X is equal to M minus BAN minus CBCM over AD minus CB, and this is all over A. Okay, so what I will have to do is I will have to combine the numerator, sorry, the two terms in the numerator to make a single fraction, and then I will divide by A. Okay, so here I will have X. This is equal to, I'm going to write it here so I have space, M. This is AD minus BC. BC and CB are the same, minus BAN minus BCM. Okay, that's an M, divided by AD minus BC, and then again we divide by A. So this is like numerator. So this A over here, that is what we're dividing by. And then you can close your bracket on the other side. Okay. So when we do that, let's see what we get. We have MAD minus MBC minus BAN minus BCM. Then we divide by AD minus BC. And then when we divide by A again, this multiplies by A. Okay, so what we want to do is, if we can simplify this, maybe this is going too long. I think it might have been easier to work out X in the same way that we worked out Y. Trying to see what can cancel. This is not really helpful. Okay, is there anything that can cancel? Yes, we have MBC and that one, yes. So these two are the same. That one and that one, those two are the same. So I'm wondering if my signs are correct. If my signs are not correct, then the way I have, because they should cancel. Let's just check. Okay, yes, my signs are not correct. This one should be positive. Okay, the reason why it should be positive is because we have a minus over here. Now this minus will multiply that one and that one, and that's why it'll become positive over there. So when it's positive, what I have is this is now positive. Then I have MBC and BCM. These two are the same because there's an M there, there's an M there, there's a B here, there's a B there, there's a C, there's a C. They're the same. The only difference is the sign, so they will cancel each other out. Okay, so be careful with those signs. And then what you have left, this is MAD minus BAN over AD minus BC. Now you can see in the numerator A is a common factor, so you can take that out. So you have AMD minus BN over AD minus BC, and then the A's will cancel. So this is MD minus BN over AD minus BC. Okay, so that is your value of X. So this seemed like a long way to go, and it might be easier just to solve for X in the same way that I solved for Y. So it's as if you start the equation again, but this time you make Y the subject of the formula and then substitute it into the other one. Because this one, it is just very long. But anyway, we get the same answers. So you can rewrite this as X comma Y. This is equal to MD minus BN over AD minus BC, and then the value of Y, this was AN minus CM over AD minus BC. Okay, and then you close your bracket over there. Okay, so that is how to use substitution to solve simultaneous equations when you have linear equations. Do we have any questions? Are we fine? I wonder if you're fine. Will you be able to answer questions like this in the test? Then you know you're fine. If you're not sure, then you're not fine and you should ask. Okay, I see you guys are ready for the test, and that's good. The next type of simultaneous equations we look at are those where one is linear and the other one is quadratic. So for example, if I have this x minus 2y, this is equal to 8, and then I have xy, this is equal to 24. Okay, so you have to solve these two equations simultaneously. Now here we cannot use elimination because both of the equations, or not both of them, are linear. So what I can do is substitution, because substitution works for any pair of simultaneous equations. So what you do is you make x or y the subject of the formula in one of them. It doesn't matter which one, and then you substitute. But always choose the equation that is easier to make the subject of the formula. Okay, so from 1, I'll take equation 1. I have x minus 2y. This is equal to 8. So then I will say x is equal to 8 plus 2y. Okay, then what you do is this 8 plus 2y, you will come and substitute it over there, become your value of x. So instead of writing x, I will have 8 plus 2y, then I put it in brackets, and show that is the whole of x, and then I multiply it by y, and this is equal to 24. Then you multiply your brackets out as usual, the y like that. So I get 8y plus 2y squared. And this is equal to 24. This is a quadratic equation. I can rewrite it as 2y squared plus 8y minus 24, and this is equal to 0. Now because it's an equation, I can divide throughout by 2. So if I divide everything by 2, we get y squared plus 4y minus 12, and this is equal to 0. Okay, and then we see if it can be factorized. You look for two numbers that when you multiply them, the answer is minus 12. And when you add them, the answer is 4. So those two numbers are 6 and negative 2. So you will open your brackets. Put y there. Then you say the two numbers are positive 6 and -2. Then the two brackets are multiplying and the answer is 0. It means the first one, y plus 6, is equal to 0. And this just means that y is equal to -6. And the second one, y minus 2, is equal to 0. This means that y is equal to 2. So I have the value of y, the two values of y. Now I need to solve for x. So remember, x, we said, is equal to 8 plus 2y. So I will substitute -6 there, I get an answer, and then also substitute 2 there, and then I will get an answer. So here I'll start with when y is equal to -6. So when y is equal to -6, I have x is equal to 8 plus 2 times -6. This is 8 minus 12. And this is equal to -4. Now when you write your solutions, remember these are pairs. So I will say -4, -6. That is a solution. They go together. And then the other one is when y is equal to 2. This means that x is equal to 8 plus 2 times 2. So this is equal to 8 plus 4. And this is 12. So you write your solution again. The x should come first and then the y. So you can also write a statement. The solutions are -4 minus 6 and 12, 2, or say something like this: when x is -4, then y is -6, and when x is 12, then y is equal to 2. So here I'm showing that they are pairs. So I'm not going to write something like this. So I say x is equal to 2. Is it 2? No, it's -4. So -4, and then I put 12, and then y is equal to -6, and then 2. This is not correct. Okay, you have to show that this x goes with this y, this x goes with that y. So not just here are all the values of x and here are all the values of y. Now you must figure out which one goes with which. Okay, so that's how to write that one. There are more questions on this. You can also try them. I'll leave that to you. So this is, remember also you need to check your solutions and see if they are correct or not. And you can try exercise 4.4.2 as well. So there are those 3 questions up here. Where I wrote them. This one, 4, 6, and 7. These are very easy. It shouldn't take you more than 10 minutes to do. And then try the questions in exercise 4.4.2. Okay, see how many you can do. All right. Do we have any questions? Any comments?
I miss.
Yes.
Miss, where can I
Yes.
find the works for these days?
The what?
I cannot find them on e-learning.
They are in the folder. I think I saw them
In the
last
what?
week. In the folder, there's a folder where you got the notes for last time.
They are not under week 8 to 9.
I think they are under there. Did you not see
But
them?
when No, I will only find the manipulation of formula, the manipulation of formula, and the other topic. But for the classes, I cannot find them, and the exercise.
Okay, let me check. Is that your mic or because it's very loud? Or
You can.
okay, that's better than not. Let me just see.
But Miss, I'm thinking it was fine when you share the classes on the group. There we can access to them easily.
Even e-learning, everything is there on e-learning. Okay, I am on e-learning right now. I see week 8 and 9 in the folder. Let me just quickly see what is in there. Sorry, it's taking long. Because I'm sure I saw them. Okay, I see it there. Under week 8 and 9, there's algebraic functions. And I think that's what we're doing. So it is there on e-learning.
Okay.
Yeah, we just need to go under week 8 and 9 and you'll get the notes to do the exercises. Okay. Any other questions?
Excuse me, ma'am.
Yes.
Where can I find work for algebraic and exponential functions?
When you
Not
say
algebraic, rhythmic and exponential functions.
which is that a previous topic or I didn't quite get that.
Yeah, the one that involves graphs and stuff like that.
I think in the book y is equal to mx plus c. I think in the
So I
notes
study.
it refers you to y is equal to mx plus c and it gives you exercises from that book.
Oh,
Yeah.
so I just do the whole of it, like logarithmic inequalities and stuff like that as
We
well.
haven't covered those. So I think if you
Oh, so
guys
then
gone through the course outline, you can see they're still coming, I believe. That if you I don't know, wait, I put my course outline. I believe those are still coming. We haven't done inequalities either. So follow the course outline. If we haven't done it in class, you won't be asked in a test to do that, obviously. Okay? So don't
okay,
worry. Yeah. I'm trying to see the course outline now.
okay, okay, man.
Okay.
Thanks.
All right. I see inequalities is week 12. Now we are at week 10. Okay, so they're coming. Don't worry.
Oh, okay.
Yeah.
Thanks a lot, man.
All right. Okay. Do you have any other questions? Yes.
Miss,
Yes.
I have a question.
Yes.
When we are solving simultaneous equation
Mm-hmm.
by elimination,
Yes.
when you find the first value,
Mm-hmm.
can you not substitute it in any equation?
You can, and I think I did that with one of the questions I was doing just now. Didn't I do that?
Okay.
Yes, I did. Okay. Uh, uh, yes. Yes. Go ahead. Yeah.
I have a question on graphs and curves.
Yes.
Yeah, when they give you like, they ask you to write the domain and the range of a curve. Then you get the next question.
Did we do that? Isn't domain and range of a function in 402, not 401? Was this a question in 401? Because I think functions, domains, and range, those we do next semester. But a domain just means your input values. Sorry? I'm pretty sure domain is next semester topic. But a domain just means your input values. What are you allowed to put in? And the range just means your output values. Okay, yeah. So maybe send me that question if it was in first semester. It might be.
So in the test, yeah, it
Was in? Say again?
in the test.
Which test?
It was in the test last year, the last question.
Last year in 401. Are you sure it was math
This test that
A?
I'm having.
Maybe can you
Yeah,
send me a picture of that? Send me a picture of that because I really want to see it. Because I know domain, range. What was the function?
They say you skip the graph. Then from there they say write down the domain and the range.
What graph were you asked to sketch?
Given the function y is equal to 1 over 4x, and then y is equal to log 4x. And then they say sketch, they start using tables, the graph of the function on the same set of axes. Clearly label the head and indicate critical points. That's 3.1. Then so they say write down the domain range of y is equal to log 4x.
Okay, for that one, when you're asked the domain, you just look at your graph, the x values. For like, if you have e to the power of x, the domain is just all the real numbers because the graph is on the left-hand side of the y-axis and also appears on the right-hand side of the y-axis. But then the range is just from 0 to infinity, excluding 0, because the graph is above the x-axis. There's no point on the graph that is below the y-axis. So domain, you're looking at your x values. What x values do you get? You get negative, you get 0, you get positive. But your y values, you only get positive ones. So that's what domain and range means. Okay. Okay, so I have another class starting in 45 minutes. So if you have more questions, you can just email them to me or send them to me here on Teams. I'll get back to them as soon as I can. So yeah, remember 5 o'clock today, the mock test should be on. So please try as much as possible to do that one. Make sure you have the scanning app, stick to the time that is given, and I think you'll be fine. So the material that will be covered in the test, I think Mr. Ndadi said it's the same as in the course outline. So you might find some of the things that we have done recently might not be in there, but it's always good to be prepared. Okay, so if there's nothing else, I will see you guys tomorrow or at 5. But 5, I don't need to do anything.